Hey guys, it's me again, Steph. And in today's episode, it's all about educating in the world of crypto. Just like space mission organizers need to have special in-depth knowledge and build a reliable space shuttle to get to space, we crypto enthusiasts need to be well-versed in the essence of the industry, understand key terms and trends in order to fly to the moon. In a news release recently, I covered a news story that included data from a study conducted by the online learning platform Proply. It was notable that 35% of crypto investors are not confident in their knowledge. This lack of understanding extends to blockchain technology as well, with 60% of investors admitting that they don't understand its concept. So let's get to the bottom of this technology. No filler, just detail in simple terms. So what exactly is a blockchain? The term itself is pretty straightforward. Block and chain. Think of it as a digital ledger that securely stores and transmits data into blocks linked together like a chain. Each block contains information about the previous one, making it nearly impossible to alter any single block without changing the entire chain. This is why blockchain is celebrated for its security and resistance to tampering. Once data is recorded, it can only be viewed, not edited or faked. Now let's take a quick trip back in time. The idea of a secure data storage in a distributed ledger dates back to the late 20th century. In 1982, American cryptographer David Chaum proposed a protocol for a distributed ledger in his dissertation, laying the groundwork for blockchain. Fast forward to 1991, when cryptographer Stuart Haber and physicist Wakefield Scott Stornetta introduced a cryptographically secured chain of blocks with timestamped records. They improved this concept by 1992 by adding hash trees, enabling efficient and secure storage and tracking of transactions. By 1995, they launched Surety, the first commercial timestamping service. Can you believe that this all started back in 1992? But here's the kicker. These early systems relied on a trusted agent to verify the data, making them centralized. Enter 2008, an anonymous entity or group known as Satoshi Nakamoto published a groundbreaking paper introducing Bitcoin, built on blockchain technology. The genius twist? Combining a chain of hash-linked blocks with a consensus mechanism to validate transactions, creating a truly decentralized system, something our team is committed to be a part of. In 2009, the first Bitcoin block was mined, marking the official birth of blockchain technology. It didn't take long for this innovation to catch fire. Initially powering digital currencies, blockchain's potential soon expanded into payment systems, banking, identity verification, gaming, and more. Today, blockchain technology is everywhere. Its applications go far beyond cryptocurrencies. Banks use it to streamline transactions, governments explore it for secure voting systems, and it's even making waves in the art world through NFTs. All right, imagine this. A programmer working abroad wants to send some money to his mom as a gift. Here's how it goes with a traditional bank. The programmer logs into his banking app. He then sends money to his mom's account. The bank deducts the money from his account and credits to his mom's account. Sounds simple, right? But here's the catch. The bank controls the entire process. They verify the transaction and store the information on their servers, which means it can potentially be hacked or altered. Plus, if the bank goes under, the money could be lost, or they could choose to just block the entire transaction. Now, let's see how this works with blockchain. The programmer connects to a blockchain network. He sets up a blockchain wallet for his mom and transfers the money to his mom's new blockchain wallet. Here's where it gets interesting. The transaction information is encrypted into blocks and copied across all computers in the network. If a hacker tries to change the transaction details, they need to alter every single computer in the network, millions of them, which is nearly impossible. Even if one computer crashes, the transaction data is still safe on all the other ones. This decentralization is what makes blockchain so secure. But there's more. Because data in blockchain is recorded in immutable blocks, any new transaction, like if the mom wants to send money to someone else, gets saved in a new block. These blocks are linked together in a chain using a process called hashing. Each block contains a unique code from the previous one, making any tampering evident. If someone tries to alter a block, the network rejects the change. ensuring the security of the chain. So in simple terms, blockchain is a method for distributed data storage and secure transmission. It's like a super secure digital ledger that's nearly impossible to tamper with. And that is it. Blockchain might sound complex, but when you break it down, it's all about security, transparency, and decentralization. Okay guys, now listen up. At the moment of making this video, our Undeads project token, UDS, has grown by 38.59% in just a day. Its price is just over $1. Check this out. We're entering more and more exchanges. We're now listed on CoinGecko and Crypto.com. On CoinGecko, we were at the top for 2 days. The daily trading volume exceeded $1 million. And our flagship game is also on our partner's website, magic.store. Join the ranks of beta testers and buy our token. You can find the links in the description below. And now let's get back to blockchain. At its core, a blockchain transaction is just a combination of data. Think numbers and letters. To turn this into a block, you need some serious computing power. In small blockchain systems, anyone can create blocks, but in massive networks, you need some heavy-duty hardware. And this is where the miners come in. Miners are like the digital gold diggers of the crypto world. Here's how it works. They grab a blockchain transaction from the queue, find a unique hash for it, link it to the previous transaction's hash, and then hash the whole operation to create a new block. Sounds simple, right? Well, not quite. The trickiest part is finding the right hash, which takes a lot of computational power. Back in the day, a regular PC could handle this, but now you need powerful mining farms to get the job done. So why do miners go through all this trouble? The reward, of course. Miners earn cryptocurrency for creating new blocks, but don't be fooled, it's not easy money. To mine effectively, you need expensive hardware, tons of electricity, and constant maintenance. Mining can seem like a golden ticket, but it's a high-stakes game. You've got to invest in powerful gear, cover maintenance costs, and pay those hefty electricity bills. It's not just about solving puzzles, it's about running a high-tech operation. I recently saw someone on social media wearing a mining backpack at a fair. I guess if you're savvy enough, you can literally mine on the go. The innovation blows my mind. So there you have it, a crash course on blockchain. From its humble beginnings to cryptography to revolutionizing how we secure and verify data today, blockchain is here to stay. I hope you found this video helpful. Make sure to like, subscribe, and hit the bell for more updates. And don't forget to join our Discord community to connect with fellow crypto enthusiasts. Happy investing, everyone! I'll see you in the next video.